SUI splits your transaction fee into four buckets. Compute covers VM instruction cycles and cryptography. Simply reading objects costs a tiny per byte fee that discourages massive state scans. Mutating an object is pricier because validators must persist a new version. The biggest slice is the one you get back later, a storage deposit equal to the permanent footprint you add to the ledger. Delete or shrink that object in a future transaction, and the deposit, plus staking yield earned while it slept, flows back to whoever authorized the deletion. Guesses waste time. Dry run gives facts. Build an unsigned BCS blob, run it through the CLI's sandbox, and inspect the printed breakdown. You'll see how many units each opcode consumed and exactly how many bytes your object updates will own. Dial the gas budget flag until it clears with headroom. Overtight budgets fail even if the dry run passes because the real cluster adds network overhead. Computation gas follows roughly the same rules as CPU time. A 1K iteration loop that merely sums numbers costs a few hundred units. The same loop that calls Kekok 256 each pass explodes. If you must touch 500 orders, pre-aggregate off-chain and submit 1 delta rather than 500 microcalls. And watch out for hidden copies. If you mark a 4 kilobyte struct copy and then pass it into 2 helpers, the VM actually clones all 4 kilobytes twice. Every byte you leave on chain is a byte every validator replicates forever. Start by picking the right integer width. U64 prices, U8 enum states. If you store 3 booleans, pack them into a single flag byte. Historical data belongs in events. Querying them is what indexers are for. When you must keep key value pairs, choose table, so deleting one row costs constant time, not vector reshuffling. Users love cashback. When they burn their expired coupon NFT, the storage fund pushes the deposit, plus yield, back into their wallet. Your contract only needs one call, object : delete. But beware the order of operations. If your token burn decrements total supply after delete, the rebate arrives in the same block, and your math might assume the token still lives. Always adjust invariance before discarding the object. A batch of 20 transfers costs far less than 20 times single transfer because the sig check and consensus gossip happen once. Push the envelope and you'll eventually smack into the validator's max gas units. Even before that, the raw BCS file might exceed the network's byte limit. Modern SDKs auto-split, but your code should still expose a maximum bulk constant, so front ends can chunk proactively. Here's the engineer's loop. Build a BCS blob with gas budget 0. The CLI chooses a dummy value. Dry run spits back the exact cost profile. We learn that minting 10 points spends 420 units on compute and deposits 1,600 units into the storage fund. If your project's cost targets 5 cents per airdrop, but current gas price translates to 7 cents, you know you need either to batch mints or compress the struct. A classic micro-optimization. 3 booleans actually pad to 3 bytes plus framing, while a single U8 packs 8 toggles. The helper functions mask individual bits so callers stay expressive. On small structs, the savings seem minor, but pack this inside a vector of 1,000 items and you've shaved kilobytes and dozens of SUI off your contract's deposit.